Hello friends, today we are going to discuss um, the practical that is simultaneous equation method. So today's aim to estimate paracetamol and ibuprofen in given tablets using simultaneous equation method by UV spectrophotometry. So requirements: chemicals required, that is standard paracetamol, that is API, then standard ibuprofen, then combination tablet, then 0.1 normal NaOH in distilled water, in glasswares, volumetric flask, pipette, beakers and funnel, in instruments, UV visible spectrophotometer and analytical panels. Then we also need Hartmann filter paper and tissue paper. Next, how to prepare standard stock solution of paracetamol. For that, we have to take 100 mg paracetamol in 100 ml volumetric flask and make up the volume with 0.1 normal NaOH. So we will get 1000 microgram per ml. That is, we can call it as 1000 ppm. ppm and microgram per ml is same. Then from this 1000 microgram per ml, we have to take 1 ml from this solution and add it into 100 ml volumetric flask and make up the volume with 0.1 normal NaOH. So we will get the 100 microgram per ml. From this solution, we have to take 0.5, 1.0, 1.5, 2.0, 2.5 in 10 ml volumetric flask. Means suppose we have taken 0.5 in 10 ml volumetric flask and make up the volume with 0.1 normal NaOH. So we will get the 5 microgram per ml. If we take 1 ml, then we will get 10 microgram per ml. If we take 1.5, 50 microgram per ml. For 2, it is 20 microgram per ml. And for 2.5, we will get 25 microgram per ml. The next, standard stock solution preparation of ibuprofen. For that, same procedure. We have to take 100 mg ibuprofen in 100 ml volumetric flask and make up the volume with 0.1 normal NaOH. So we will get 1000 microgram per ml. From this 1000 microgram per ml, we will take 1 ml and take it into 100 ml volumetric flask and make up the volume with 0.1 normal NaOH. So we will get 100 microgram per ml. Then from this 100 microgram per ml, if you take 0.5, 1.0, 1.5, 2.0, 2.5 and take it into 10 ml volumetric flask and make up the volume with 0.1 normal NaOH. So we will get, that is 5, 10, 15, 20 and 25 microgram per ml. These are the working standards. Then next, label claim. We have taken this tablet which contains, each uncoated tablet contains ibuprofen IP, that is 400 mg, and paracetamol IP, that is 325 mg. So average weight of 20, we have taken 20 tablets, individual weights, and then we make average weight of that 20 tablets, and it is 1000 milligram mg. Then so we have prepared standard stock solution of paracetamol, standard stock solution of ibuprofen. Then we are going to prepare sample solution, that is sample mixture, that is tablet. For that, we have taken 20 tablets and the average weight of 20 tablets, it is 1000 mg. So we have to calculate the equivalent weight. Suppose there is 1000 mg tablet powder. In 1000 mg tablet powder, 400 mg is ibuprofen. So we have to take 100 mg. So for 100 mg, we have to calculate equivalent weight. So in 1000 mg, there is 400 mg ibuprofen. So in 100 mg ibuprofen, for 100 mg ibuprofen, how much powder we have to take? For that, x is equal to, we will cross multiplication. We will do cross multiplication. That is 1000 to 100 upon 400. It will give 250 mg. So we have to take 250 mg. That is equivalent weight. So take 250 mg tablet powder in 100 ml volumetric flask and make up the volume with 0.1 normal NaOH. So we will get 1000 microgram per ml, that is 1000 ppm. From this 1000 ppm, we have to take 10 ml into 100 ml volumetric flask and make up the volume with 0.1 normal NaOH. So we will get 100 microgram per ml. And from this 100 microgram per ml, after preparing this 100 microgram per ml, we have to filter it by using Waterman filter paper, and then from this 100 ml 100 microgram per ml stock solution, after filtration, we will take 2 ml and we will take 2 ml in 10 ml of volumetric flask and make up this volume with 0.1 normal NaOH. So we will get 20 microgram per ml. So here we have taken 250 mg for 100 mg of ibuprofen. So in that 250 mg of tablet powder, how much will be paracetamol? So we have done cross multiplication. We have got this value, that is 81.25 mg. So in 250 mg there is 100 mg of ibuprofen and 81.25 mg of paracetamol. So we have to, if we take 81.25 mg in 100 ml by make up the volume with 0.1 normal NaOH, so we will get 2.5 micron per ml. We are not going to take it again. Already we have taken 250 mg in 100 ml volumetric flask, so it is already there. So lastly, if there is ibuprofen, by taking 2 ml from that 100 ml of 100 microgram per ml, we have got 20 microgram per ml ibuprofen, and in this you will go that is 16.25 microgram per ml. Now after preparing standard stock solution, we will going to measure the absorbance at both the wavelength, that is lambda 1 and lambda 2. Lambda 1 is 222 nanometer, that is ibuprofen, and lambda 2 it is 257 nanometer for paracetamol. Then we will measure the absorbance of working standards of ibuprofen, that is 5, 10, 15, 20 and 25 microgram per ml. And for paracetamol, it is 5, 10, same 5, 10, 15, 20, 25 microgram per ml. After that, we will measure the absorbance of sample solution, that is mixture of ibuprofen and paracetamol. Next, this is the simultaneous equation. By using this equation, we will determine the concentration of Cx and Cy, that is concentration of ibuprofen and concentration of paracetamol, where Ax1 it is the absorptivity of ibuprofen at lambda 1, then Ax2 it is absorptivity of ibuprofen at lambda 2, and then Ay1 it is absorptivity of paracetamol at lambda 1, and Ay2 it is absorptivity of paracetamol at lambda 2. Then A1 is the absorbance at lambda 1 and A2 is the absorbance at lambda 2. This A1 and A2, these two are the sample mixture, absorbance of sample mixtures. Then Cx is the concentration of ibuprofen and Cy it is the concentration of paracetamol. So how to calculate the absorptivity? There is a formula, capital A is equal to ABC, and we want, that is A, it is absorptivity. So A is equal to capital A upon BC, where A is the absorptivity, capital A is the absorbance, B is the path length, and C it is the concentration. So by using this formula, first of all we have got these are the concentration of ibuprofen. Then we have got the absorbance at 222 nanometer. For 5 it is 0.276, 10 it is 0.312, then 0.486, then 0.629, and then 0.832. So same likewise for 257, these are the absorbance. And then we have to calculate the absorptivity. So formula for absorptivity we have seen, that is A is equal to A upon BC, capital A, that is absorbance. So here absorbance is suppose for 5 microgram per ml. If you want to calculate the absorptivity, so we will take A is the capital A 0.276 upon BC. B is the path length, that is 1. So we will take 0.276 upon concentration, that is 5. So we will get the absorptivity. Likewise, we have calculated for this concentration, for these absorbances, these are the absorptivity. For this, these are the absorptivity. These are the for lambda 1 and these are the for lambda 2. From this, we have taken the average AX1, here AX2. Same for paracetamol, we have taken these 5 working standard, and these are the absorbances. For lambda 1, these are the absorbances, and for lambda 2, these are. Then from these absorbances, we have calculated the absorptivity. So we got AY1, it is 0.018, and AY2, it is 0.032. Here AX1, it is 0.037, and AX2 0.010. And last, sample mixture. We have taken the absorbance, we have measured the absorbance of sample mixture, and we got A1 is equal to 0.894 and A2 it is 0.726. So by using these values, that is AX1, AX2, AY1, AY2, and A1 and A2, we will calculate the unknown concentration of ibuprofen and paracetamol. So we will use this formula to calculate the unknown concentration of paracetamol. We will use this CY, this formula, and for ibuprofen we will use this CX formula. So by using this formula, CX is equal to, we have put these values and we got 15.47 microgram per ml. This is the unknown concentration of CX, that is ibuprofen, and for CY we got 17.85 microgram per ml, that is for paracetamol. So last, that is the result. The simultaneous method of UV visual spectroscopy was used to determine the unknown concentration of ibuprofen and paracetamol in the given sample, which was found to be, that is for ibuprofen it is 15.47 microgram per ml, and for paracetamol it is 17.85 microgram per ml. Thank you.